The Hooks tool chain leverages many products from well-respected companies in model-based software design and development. The Hooks tool chain includes the Hooks block library and driver software in addition to existing tools from the MathWorks and from Freescale. The Hooks tool chain can be separated into three pieces: development environment, compilation tools, and HMI. The development environment is the Simulink model, where the controls algorithm is created by the engineer. The compilation tools convert the engineer's controls model into binary code that runs on the target device. Finally, the HMI allows the engineer to monitor and calibrate the target during the development and testing phase. The Hooks software environment combines the power of the MATLAB and Simulink tools from the MathWorks with additional flexibility provided by the Hooks block library, allowing the applications engineer to easily create control algorithms. This model-based approach allows for rapid development of control algorithms by simply dragging and dropping combinations of standard Simulink library blocks and Sturman Hooks library blocks. Once the model development is complete, the model needs to be converted into binary instructions for the target device. The compilation tools used in Hooks development cycle operate in a three-step process. First, the MATLAB coder, embedded coder, and Simulink coder tools from the MathWorks convert the application engineer's Simulink model into C source code. Second, the newly created source code for the model is combined with the Hooks OS and target hardware drivers developed by Sturman to create a complete set of C code. The last step uses Freescale's Code Warrior compiler to convert the C code into an executable binary for the desired target. The HMI component of the Hooks toolchain is the Sturman Calibration Editor, or Scale. Scale uses a directory tree structure for the navigation of calibration variables, vectors, and tables. Scale has the ability to communicate via several different protocols, increasing flexibility during system testing. Sturman is continuously advancing the Hooks toolchain and is pursuing additional industry partnerships with automotive controls and software companies. This segment will provide a demonstration of just how rapid prototyping can be with the S-Tech and Hooks products. The demonstration will perform the complete S-Tech algorithm development process from modeling, generating code, building, loading to a controller, and testing with hardware. Stay tuned to see how fast you could design your next engine controller. In this example, we add a pulse width modulated turbocharger actuator to an existing engine control model. After opening the Simulink model and the block library, navigate to the desired location for the new device. In this model, actuators have been grouped together at the model's base level for readability. The new turbocharger will be implemented as a subsystem inside this block. Start by dragging a subsystem block onto the model from the standard Simulink block library. Inside this new turbo subsystem, build up the turbo components. The Sturman Hooks block library, shown at the bottom of the Simulink library browser, contains library elements customized for the S-Tech family. In this case, we are working in a Sakai environment. These custom blocks include low-level functionality that implements the inputs and outputs available in the Sakai hardware. The PWM output block enables a PWM command to be sent to any PWM output channel on the Sakai. The block mask allows the user to specify which PWM channel will be used and the PWM frequency. In this case, the turbo is connected to channel 2 and operates at 128 Hz. The turbo PWM command is a function of both engine speed and commanded torque. This functionality is implemented via a lookup table. The table parameters are defined within the block mask for the scale lookup table, another block from the Hooks block library. The RPM input into the table is provided by the EPT RPM Hooks block. The torque command input to the table will be generated algorithmically by existing parts of the engine control model. However, for purposes of development and test, a scale input parameter block from the hooks library is used to provide the torque command. Finally, a scale display table block from the hooks library provides visibility of relevant values to the operator. All scale functionality, including lookup tables, parameter inputs, and displays, is available to the operator for calibration from the scale user interface running on a PC. Next, a build command is input to the MATLAB command prompt. This build command will generate code for the model and then compile it using the Freescale Code Warrior compiler. Once complete, a binary executable file is ready to be loaded to the Sakai. Open Scale and connect to the Sakai controller. Use the Flash utility to flash the binary image into the controller. Next, either load and flash an existing calibration file or edit the tables to create a new calibration file. After resetting power to the Sakai, the algorithm changes are ready to test. Notice that the operator can now change values in the torque table on the scale user interface. The command changes are sent down to the Sakai, and the system responds by changing the PWM output. And, in turn, moving the turbo's wastegate actuator. In only 6 minutes, a complete turbocharger control algorithm was added to this engine controller.